Just a couple of housekeeping things. I have posted a couple of videos for this week. That's for you to watch. Treat it as a homework, and they are right here. This is our YouTube, our class YouTube playlist, and the structure is, as you could probably notice, that the top part of that is all the lectures, and the bottom part of it is all the labs. So these are all the lectures, whatever we have done so far. This is yesterday's class and repeat, and we have finished on that. Yes, I mean last time we saw each other, fire alarm and surveillance, and here are these two entries right there. We gotta do the optical fiber or fiber optics. So in this videos, there's the first one is an introduction to optical fiber. So it's the principles of operation and so on, how they work actually. And there are within that presentation, which you already have available for download in the posted lecture notes. There are some links to some short videos. Right, those are also for you to watch. Okay, and then when we come back, we're going to look at some of that, some of those concepts, and if there's any questions or any things that details you would like to cover in greater detail, you're welcome to. We're going to designate some time for that. Okay, for the Q&A period, as far as that goes. All right, and the reason why I want you to watch those videos, I did them a year ago. And they came out just right, so I'm just not sure if I can repeat that in exactly the same way. So I want you to have that in the best form that I can possibly give you. So those two videos are pretty good as far as I'm concerned. Okay, so watch these two. Here's one. They're named a little bit different. But you can see the fiber optics 1 of 2 and fiber optics 2 of 2. First is the first part of it is the principles of operation, and the other part is the practical applications of that. We are also going to have a lab on that. We're going to perform a fusion splice on a couple of single mode strands using a fusion splicing machine. All right, so that's as far as that. Okay. Right. As I said before, I'm pleased to see that your documentation is looking more and more as professional, to the point that you could actually, the way you are presenting yourself on the documentation that you're providing as the lab documentation, you're pretty much ready when it comes to providing some of the deliverables to your employers. Only one thing, just to repeat, is that when you are listing the materials, when you have the list of materials on as a part of the deliverables, just don't list the tools that you have used. The client doesn't care that you have used this kind of a screwdriver or side cutters or things like that. Just list the billable materials. That's the purpose of that section right there. Okay. Right, so let's jump on to our continuing. Let's continue from the last time we took off. Now, here is the zone, typical zone. What is just as a reminder, what is a zone in a security or fire alarm? This is a typical security alarm zone. Zone is a contact point, and the boards will have contact points right here. Okay? And these are called zones. Let me see here. That's a magnification of that. So here's the section that consists of the zones, and zones are contact points. So zone number 1 in the security alarm has to be usually, okay, sometimes there are different scenarios, but basically it has to be shorted to the common. Okay, so Z1 shorted to common, Z2 shorted to common, Z3 shorted to common, and then based on that, the security alarm thinks that everything is okay, the zone is at rest. If something happens, like for example, the door is opened, so the read switch opens, then the zone 1 would be opened. And then there would be a condition. And if the security alarm is armed, it would be probably an alarm condition. Or if the security system is not armed, it would give you an indication on the panel that the door is open. Now you can combine those devices in series. The whole point is that the loop is closed. So you can combine those devices in series, just like this. So there we go. Just like this. So this could be, let's say, door contacts. They're generally called door contacts. Okay. It's a read switch, which is a magnetically operated switch. When you put the magnet close to it, in the close proximity, the switch closes and remains closed until the magnet goes away from that. So the sensor could be on a door frame, and the magnet could be on the door itself. When the door comes in close proximity to the sensor, then the switch is being closed. It will be a passive device. In active device, let's say a motion sensor, the circuitry would have a dry contact relay that is closed if there is no motion detected. If the motion is detected, then the circuitry inside the motion sensor is going to open the relay contact, and the loop is going to be opened. So let's say these are 1, 2, 3 motion sensors in a certain area, let's say a living room or something. It has 3 motion sensors in different parts of the room. And if the system is at rest, all the switches are going to be closed. So there's going to be a closed loop. If one of them detects motion, it just takes one of them to open, and the whole loop is open. So that's in series. Same as you can put the door contacts on windows. And if there's for example, a living room, and the door is all the windows are closed, then all the switches would be closed. As soon as you open one window, then the whole loop is open. Okay, so you can save the zones, because yes, you can put all the windows on separate zones, but you're going to run out of zones in the security system. So in order to save the zones, the amount of zones that you can use that will be available for you, so usually the boards for the security alarms, they come in 8-zone capability. You can get expansion boards, or you can combine them in something that's called end-of-line resistors / the loop. So then we talked about that last time. So this is how the zones are solved in the security alarm. In the fire alarm, it's going to be a little bit different. Okay, so I just gave you the kind of repeat from last time. Now let's go and take a look at the fire alarm. Let me just let this thing settle. Okay, so as opposed to security alarm, there is a fire alarm system. Okay. So the basic parts of that would be the main panel, and you would have zones in there as well, which would be the contact points. They're organized slightly different than the security alarm. Security alarm, the zones, the zone is looking for a closed loop. It's looking for a zero resistance. It's looking for a dead short. Okay, to be at rest. Okay. And we'll talk about a couple slides down the road here. In the fire alarm, the zone is not open, not closed to be at rest, but it has to see a resistance, a certain type of resistance that we are presenting it in the form of something that's called an end-of-line resistor. And we'll talk about that in just in about a couple minutes. All right, so what do we see here? We see the annunciators, and the annunciators are in the form of strobe lights and, well, some sort of a bell. Bell is a generic name for a device that makes noise, right? So the technical lingo would be a bell. It, you know, in the old days, it would actually be a bell that rings. Now there are electronic devices that make noise, but they still call them bell. It's still a bell, all right? That's the terminology, right? So there will be a noisemaker, strobe light flashing, and the noisemaker has to make a certain level of noise as far as volume, and that is regulated by the rules and regulations. Well, usually they are being listed in fire code. So you are right now you're studying electrical code, but there's also another book which is just as thick that is called a fire code, right? And that is for the fire alarm or the fire people, fire related industry. Now also some of the annunciators, they also incorporate a loudspeaker in order to make announcements. Okay, so we'll talk about that too. Then you would have, there will be also different type of annunciators. Now you have devices, triggers, because for the alarm system, fire alarm system to work, you have to have something that triggers it into an alarm condition. So basically in that would be smoke detectors, or I'm gonna wait for the phone to stop ringing. There's no one here in the office and the phone is away from me. So I'm just going to, let's just ring, banana phone. Okay. All right. Okay. All right. So as far as the triggers for the alarm systems, it would be smoke detectors, or heat detectors, or manual pull stations, or manual triggers. So sometimes you want to install a smoke detector because it's more efficient for that type of environment, and sometimes you might want to install a heat detector because it is more efficient for a certain environment. Like for example, in a hallway, you would mostly install smoke detectors because smoke would be the first indication of something that there's a fire in that type of environment. When you're talking about places like furnace rooms, right close to furnace, and sometimes really above that, there would be something that's called a heat detector, because heat would arrive first, then the smoke. So it would be more efficient to put a heat detector there, and the heat detector triggers upon a certain amount of heat that is surrounding it. Okay, and then of course we're going to have pull stations, and you see them all over the place in the hallways, that anybody can walk up there in case of a fire, and then you just pull the pull station and trigger the fire alarm. You should not be doing it if there is no fire, okay, because you can get in trouble for that. Okay, now also what is involved in the fire alarm panel, it would be a communication section as well. So this fire alarm can be connected to a telephone line, to regular POTS line, or it could be connected to a network in order to communicate with the monitoring station. Same as the security alarms, also the fire alarms, they do not connect directly to the fire station per se. Right? So the fire alarm is not connected to a fire station. Security alarm is not connected to a police station. Security alarms and the fire alarms, they are both, when it comes to monitoring, they're connected, they communicate with a monitoring station, with monitoring stations. And monitoring stations are businesses, they are facilities, they're companies that basically all they do is provide the monitoring service for fire alarms and for security alarms. And then based on a condition, such as a burglary condition or a fire condition, then the monitoring station gets a signal, and the monitoring stations, they do have human operators 24/7 on duty, and they monitor the whole area. They have hundreds and hundreds of systems that they monitor, so there should be, usually there will be people who can handle the volume of whatever the troubles might arise in the area. So they respond to that. They receive the signal, pops up on the screen, and they have instructions based on whatever zone was triggered on whatever systems. So sometimes if it's a security alarm, then if something is triggered at some facility, some zone, they get instructions of call the premises first, or maybe call the owner of the company, and then if they can be reached, then the instruction would be call the police. Right. So same thing with the fire alarm. Fire alarm is more strict. If there's a fire, they also have instructions. There could be some communication between the facilities management or whoever is on duty there, the management on duty, or if it's a residential, then it's trying to call establish the communications with that. But it happens very quickly, and if there is no communication that can be established, then the fire procedures are triggered, which would be calling the fire station. All right, so that's as far as the communication goes. All right. There's just another visual. Aside from just the main panel, there could be other satellite panels for fire alarms. This could be a remote panel. Like, for example, this would be the main fire alarm panel somewhere in the building. And then if the building is large enough, it has different areas, those satellite panels can be placed in different areas of the facility. So if there is a fire alarm triggered, then somebody can walk up to the panel, whether it's the main panel or satellite panel, and try to figure out what is actually happening. And on the display, there will be an indication on, let's say, smoke detected in some air ducts. Or there will be a heat detected in furnace room, or pull station pulled in the east wing, door number 7, or something like that, right? So this would be something that looks like that. There will be a satellite panel, and another satellite panel would be something like they could look like this. This is just an annunciator that would just help you with identifying the condition, right? And also there's some other paraphernalia, like, for example, this one is called a smart relay module. So this would have relay contacts and other triggers that could be interfaced with other systems, like, for example, with security system. Well, why would we have that? Well, the security, the fire alarm can be connected directly to the monitoring station, or it can be connected to one of the trigger points or zones in the security alarm, and the security alarm could be connected to the monitoring station. So if this fire alarm could be connected to if it is connected to one of the zones, and that zone is named as a fire alarm zone, and will actually be programmed to be triggerable 24/7, so the security system doesn't have to be armed if there's a fire condition. If that zone is tripped, then things happen. All right. It could be going into alarm, or it could be announcing or initiating communications with the monitoring station. Right. So you can interface things back and forth. You can connect security alarm to a fire alarm, which is not likely. Usually would be that the fire alarm would be connected to a security alarm, which is connected to a monitoring station. Right. So there are different paraphernalias or different modules that can be interfaced with that. Right. So here is, remember when I showed you the security alarm? Security alarm, I'm just gonna go and, where is it? No, that's not it. There you go. Remember, security alarm, the zone looks for a closed loop. So the devices would be connected in series. As soon as one opens, then the whole thing triggers. Okay, now, as opposed to that, there's the fire alarm zone. Went too far, way too far. Okay, here it is. Press it too many times. Okay, so here's the typical zone for a fire alarm. Okay, notice that all the devices are open for the condition to be considered as at rest. Okay, so now, but look at this thing here. This fire alarm zone has a loop. So if these switches are open, it's just like if they don't exist. It is looking for the end of line resistor. Okay. Now, I have listed this one as 47 kilo ohms, but depending on the brand and the model number of the fire alarm, the values can be different. It should be the one, the resistance value should be the one that is basically indicated in the manual, okay, of the fire alarm. When the situation is at rest, the fire alarm zone looks at the end of line resistor, and if it sees the value of the resistance that it's looking for, then it's considering that zone as it to be at rest. So everything is okay. Okay. Now, what happens if the cable is broken? Something, somebody does some works and by accident they rip the cable apart. So then the zone would see no resistor at the end of the line, and it would trigger, but it would trigger into something that's called a trouble condition. A trouble condition is not a fire condition. It's a trouble. It is basically what it is. It's a trouble, which means there's a trouble with the line. Something is not right with the system. So if something is not right with the system, then the detectability of the fire conditions might be compromised. So if there's a fire, the system might not recognize it as a fire. Right? Well, because the wire is broken, for example. Right? So the trouble condition would manifest itself as continuous, annoying series of beeps or buzzes or noises that the panel would make periodically, to the point that it would get the interest of the people who are in the facility, and they will be they would start looking where those noises are coming from. Oh, it's coming from the fire alarm panel, okay, and it says trouble. Oh, look at that! And on the fire alarm panel, there's a phone number also that says, in case of trouble, call, or for service, call this number. So they would call the number and they would say, yeah, there's some. The alarm system is beeping and it's showing trouble. All right, so of course there will be some conversation. Is there a fire? No, there's not. Blah blah blah. So they would just dispatch a technician to see what's wrong with the system, and usually it would be a ground disconnected from the stations, or it could be a break in the wire. So for this reason, well, I have seen, because I have done some fire alarm systems in the past, I have seen some bad installations in my past, where I come over to the fire alarm panel and I can see that the end of line resistors are being mounted right at the panel. That is a huge no-no, okay? The end of line resistor is supposed to be an end of line resistor. So if the line is broken, the system will not see the resistor. That's at the end of the line. If you put the resistor right at the panel, if the line is broken, the system is still going to see the resistor. So if the line is broken and the devices will not annunciate the fire, then what's the point of having the whole system, right? It's not going to be able to. So recognize the condition. So you need to have end of line resistors should be at the end of line. Nomen omen, okay, which means the name defines its functionality. It's a Latin expression. All right, so so it should be at the end of line. Now, what happens if something is triggered? Then, as opposed to the security alarm, the switch will be open upon a condition. Then in fire alarm, it's the opposite. The device is being closed. So then then the zone sees a dead short. Any of those devices can close, and it is going to short the contacts, and in this case the fire alarm is going to trigger into a fire condition, and then it's going to start making noise, and all kinds of chain events are going to be triggered. Right? So that's how the zone works in the fire alarm system. Now, with the fire alarm sensors, just a little bit of a synopsis of what is involved with the fire alarms. Sensors would be mostly heat detectors, smoke detectors, and manual pull stations. We just talked about that. Annunciators would be a bell, which is the siren, or some sort of electronic device that makes noises of a certain volume that is required, and or a strobe light. Okay, now depending on the area you're in, but pretty much most of the time, you're going to be required to provide some sort of audible noises and a strobe light as well. Right? Control, or let's just look at this thing here. Interfacing. What can the fire alarms what can they be interfaced with? Well, the fire alarm can be interfaced with a security alarm, which we just talked about that. The fire alarm doesn't necessarily have to be directly connected to a monitoring station as far as communication goes, outside communication. It could have a relay contact that would operate based on the fire condition. Then that could be connected to one of the zones of the security alarm, and the security alarm is going to recognize the condition as a fire, and is going to it's going to trigger a communication with the monitoring station, and it's going to basically trigger again a bunch of events based on that. All right. So monitoring, it could be interface with monitoring directly as well. Now, the fire alarm can also be interfaced with sprinkler systems. Now, I'm just going to talk about the sprinkler systems, just give you the general idea of sprinkler systems. A sprinkler system is a plumbing system. A sprinkler system has a bunch of pipes in the ceiling that are filled with water if it is something that's called a wet sprinkler system. There are wet and there are dry sprinkler systems. In the wet sprinkler system, the water is present in all the pipes all the time, and the water is under pressure. The pressure is monitored by the main panel of the sprinkler system, and if the pressure doesn't go down, if the pressure keeps at whatever level it's supposed to be, then the sprinkler system excuse me, is at rest. If the pressure goes down for whatever reason, then the main panel of the sprinkler system triggers. Basically, it lets the monitoring station know that the pressure has gone down. Now, sometimes there will be false alarms. If there is a water pressure or the city pressure goes down, and if the pressure in the sprinkler system depends on the city pressure, and if the pressure of the water goes down and it goes below a certain level, then the communication of the sprinkler system can also trigger, notifying that the pressure has gone down. So then whoever is monitoring the facility would be notified, and they would be required to go into the sprinkler room and look at the sprinkler system and look at the pressure gauges and so on. So if they see that the city pressure has gone down, and based on that, the sprinkler system pressure has also gone down, then it could be considered as a false alarm. But usually the pressure goes down below a certain level is if one of the sprinklers is triggered. If how do you trigger a sprinkler head? Well, if there is a fire, the heat that is present is going to melt that little trigger sensor in the sprinkler head, and that thing is going to break and release the water. And usually 99% of the time, the only sprinkler that is going to be activated is going to be the one that is affected, right? All the other ones are not going to spray water. That's the only one that's going to spray water is the one that was affected by the heat and it was triggered. And it's not like in the movies that you break one of them and the whole system goes nuts, just spraying water everywhere. Yes, there could be a system like that, but it will be by a special request. So yes, the system could be set up that way, but for the most part, it's just the one that is triggered is going to spray water. All right. So when one of the sprinkler heads is triggered, the water is being sprayed, which means the pressure in the whole system is going to go down because there is a release of the pressure in that sprinkler head. So then the system is going to trigger into a condition, and that could be connected directly to a monitoring station, or it could be connected to a fire alarm, which could be connected to a security system, or could be connected directly to the security system, which is connected to the monitoring station. Those type of connections should be verified with the rules and regulations that apply to the area you're in. So now, okay, so I talked to you about the wet sprinkler system. Okay, now sometimes something that is called a dry sprinkler system are implemented because, well, depending on where they're installed. If the system is installed in the building that there's a regular heat supplied and the temperature is at a certain level and so on, the water doesn't freeze. Yes, for the most part, it's the most efficient system because the water starts coming out right away. So it will be a wet sprinkler system because the water is present in the pipes all the time. Now, if it's a sprinkler system that is installed in like an outside garage, like a story garage, outside parking lot, then everything is, even though there's different stories, different levels of the parking level, but everything is outside. There's no walls. It's considered to be an outside environment. And if it's winter, then the water that's in the pipes could basically freeze. So the system could be not very well operational, would it? Because the water would be frozen in the pipes, and the pipes could break because of the expansion of the water when it turns into ice and so on. So in this case, some that's called dry sprinkler systems are being installed, so there's just air in them, and if one of the sprinkler heads is triggered, then the water from the main panel then is being released into the pipes, so it could extinguish the fire at wherever area that is. So there's a difference between dry and wet sprinkler systems. Okay? Now this fire alarms also can be interfaced with the PA systems. So the annunciator could have a noise-making device, it could have a strobe light that's flashing, and it could have also a loudspeaker incorporated in that annunciating module. And the speaker is basically for the purpose of annunciating, look, this is a false alarm, or this is a drill, or this is not a drill, please get out of the building now. And that would trigger all kinds of procedures involving people who are involved in the procedures of getting people out of the building. So the PA systems do work together with the fire alarms. It doesn't have to be, the PA system doesn't have to be part of the fire alarm. It could be a separate system, but it has to be operational. Basically, so the announcements can be made. It could be a totally the PA system could be a totally different standalone system, which is not interfaced with that, as long as the PA system is there. And most of the commercial facilities require to have a operational PA system for that purpose, mainly for being for the safety reasons, so you could annunciate things. Right? Now, kitchen fire suppression. The fire alarms also can be interfaced with kitchen fire suppression. If you have like kitchen fire suppression systems, right? So if you if some of you are working in some fast food restaurants or restaurants, that they have cooking station or grilling station or whatnot, then you're going to see some sort of piping on top of the kind of under the hood that covers the outtake van for the fumes and so on. And there will be some nozzles. There will be pipes with the nozzles. Those nozzles are basically the fire suppression system. Okay, so when there's a fire in the kitchen, okay, then this fire suppression system would trigger. It has a sensor in the form of some material that is holding two springs together, or a spring-loaded system, and it's preventing it from being triggered. If there's a fire, that piece of material is going to get burned, and it's going to basically break, and it's going to release the spring-loaded system, and that basically manually is going to trigger the fire suppression system. So in the fire suppression system, the nozzles would spray a fire suppressant or oxygen suppressant first, so basically to starve the fire out of the oxygen. So this just to put it out, and it's going to come out of those nozzles for some time, for I don't know, a minute or so. And after that, the next step would be spray water. And the purpose of that is to cool things down, because first you suppress the fire, but things are still hot. You starve it from oxygen, the system, the whole, whatever happened there, it could be still hot. So there could be a possibility of reigniting this. The fire could reoccur. So then the water comes down to cool things down, so the fire doesn't reignite. Okay, so that's the fire suppression system, and the fire suppression system also could be interfaced with the fire alarm. The contact that is operating in the main panel of the fire suppression system can trigger a zone in the fire alarm system. So that's how we interface things, right? And of course, some other systems that I just have to put that there, okay? Because that's not limited to that. Okay, so control. How do we control the fire alarm panel? Control fire alarm panel. You can control it through the laptop in order to basically program that, or monitoring the conditions, but usually for programming it or setting things up. You can have an IP interface, which you could connect the fire alarm panel to a network, your local area network, LAN system, and you can remotely access as well, usually through IP. Now, a couple of things here. When it comes to fire alarm systems, there's electrical code in effect. Same as with the electrical installations, you have to abide by the electrical code. And with the fire alarm systems, there is also a book which is just as thick, and it has to do with the fire code. Yeah, so there's electrical code and there's a fire code. Also the electrical code in effect is has to do with the type of installation. So sometimes you need a licensed electrician to connect a fire alarm system, and sometimes you will have to have a licensed electrician that is trained to install fire alarm systems. So additional licensing is involved. Our college does offer that type of a training, this type of a course. Other colleges as well, but we do also offer that. So if this is something you might be interested in as a fire alarm technician, or something that has someone that has something to do with the fire suppression systems and so on, talk to me and I will point you in the right direction. I'll tell you who to contact if you're interested in that type of career. Okay, so there goes that slide. All right, cables that are involved with the fire alarms. The cables are supposed to be, well, they're supposed to be fire cables. You can't just use any cable. It should be fire rated, and most of that, well, pretty much is going to be FT6 rated, FT6, as opposed to FT4, which is not really good idea for the, not a good idea. Not. Well, can I find something that writes here? It is not a good idea. FT4 is not a good idea. FT4 and FT6 is that has to do with the jacketing of the cable. And FT4 and FT6, as far as fire alarm systems and the infrastructure wiring, it is a part of your electrical code. So I encourage you to find that section in the electrical code. Where are you supposed to install FT6 jacketed cable or FT4 jacketed cable? If, for example, if you have a data cable that is FT4 or FT6 rated, the functionality of that cable makes no difference whether it's FT4 or FT6 rated. It has to do with the jacketing. FT6 does not burn as quickly as FT4. It's basically considered as fire retardant. Okay, so or fire resistant. So basically, it doesn't burn as much as FT4 would be burning. It requires way more temperature for this thing to start burning. Anything can burn, right? But FT6 burns a lot later than FT4 would. So that has to do with releasing the toxic fumes into the air. So FT6 would be, there will be FT6 rated fire alarm cables. And the type of cables, depending on the situation, you might have to use a fire alarm cable which is unshielded, and you can see that there's 1, 2, 3, 4 solid strands in there, and of course they will be not twisted because there's no need to twist for that. There's no signal going on. It's just a condition open and close. And you can also have a shielded, foil shielded alarm cable for the purpose of not introducing the noise into other devices. There's a lot of noise going through those fire alarm cables, and those cables can affect other things. Like they can affect data wiring, they can affect other devices that are in the ceiling or in the walls that are close to it. So sometimes you might have to be required to install a shielded cable, and sometimes you're going to be required to have fire alarm armored cable with aluminum armor there, and sometimes you're going to have armored and shielded cable, right? So that's basically the cabling that is involved in fire alarms. Okay. Now, so that's it for the fire alarms. Now we're going to quickly go over the security surveillance. So surveillance is basically it's the security cameras. Okay. Now on this picture you can see a monitoring station of a system that has to be monitored 24/7. There could be some sensitive facilities that would require a human being watching the cameras all the time. Right? But quite often, when you install the security cameras or the surveillance systems, they're basically standalone, and there's something that's called a DVR or NVR. DVR or NVR, digital video recorder or network video recorder. Okay. They're pretty much the same. They're almost like exchangeable terms, but technically they're not. DVR would be a digital video recorder and it's supposed to record, and that's it. And NVR is a DVR that is networkable, which uses, you can connect it to a network. However, most of the DVRs have the networking capability, so it is kind of exchangeable. But NVR, DVR, you're going to hear that people loosely exchanging those terms, but basically that's what it means. Most of the time right now you're going to see an NVR. Okay? So the NVRs can be, or DVRs can be accessed from outside because they are networkable. So you can view your own house on your cell phone, you can view your own house on your laptop and on remote computers and whatnot. So the possibilities are quite, I wouldn't say endless, but are huge. Okay, it's a standard thing right now. Now, when it comes to connections of a security camera, it used to be in the good old days, as some people say, just the camera. The camera would have two connections to it. It would have a coaxial cable connected to it that would be responsible for transferring the video signal onto a video recorder, and then you would have a one pair stranded, for example, 16 gauge, one pair which would provide the power to it, and then different cameras would require different type of power. Sometimes there would be cables that would be sold on the market that would be called Siamese cables, just like Siamese twins. So there would be a Siamese cable that would, in one jacketing, it would be coaxial cable, and it would be also it would contain also a one pair stranded for power. Right? So just so you don't have to run two cables onto into the camera. So those would be there. Now, right now, actually, you can still see some of the old systems that are installed that way. It would be difficult to buy a new system. However, some of those are still being sold, the cameras that or the systems, for the purpose of retrofitting. If somebody doesn't want to go Ethernet on the cameras, so IP cameras, and they don't want to pull new cables, but they just want to replace the cameras or replace the head end. So still you might see some distributors carrying some of the old design of the system of the cameras. However, now the way to go is IP, right? So the cables that are used to connect the cameras would be Ethernet. Yeah. So that's why we try to give you as much practice as we can in order for you to properly connect the Ethernet cameras. Okay, and sometimes, remember when I told you when we're doing the Ethernet patch cord, you can buy those patch cords for very, very cheap right now. So why would you want to make one? Just getting the parts for it would be more expensive than buying the patch cable. Well, sometimes you're going to have to put on Ethernet plug onto the cable itself that you're going to pull to the location where the camera is, and this would be one of the situations. Now, what you could see here, there is a power adapter or a power jack and the Ethernet jack. You can power the camera locally from one of the local close by power outlets that you can plug in the transformer, from the transformer, the power transformer, and you can connect that to the power. Now, I kind of discourage that kind of a thing, because when you're powering the cameras from different locations in the facility, and the facility is big enough, you could end up into a problem that there could be some what's called the ground loops, because the grounding or the neutral cables could have slightly different levels on different panels, and in the audio system that manifests as buzzing, and in the video system it manifests as some interference on the video signal. There could be some stripes running through or something like that. So if that's the case, if you want to power up from using this type of jack, then the power distribution for all the cameras should pretty much be in one place, so they're coming from the same electrical panel. However, quite often what you're going to see is that the cameras are being powered from PoE. PoE is power over Ethernet, which means the Ethernet cable not only is responsible for connecting the signal back and forth, for directing the signal back and forth or carrying the signal, but it also, in some pins, there would be usually 48 volts DC power in some pins, and that when this thing is connected to the receiving end, then there's a circuitry that discriminates between the power and the signal. So that's the idea of PoE. Now, I just mentioned something that's called 48 volts DC. However, some of the camera systems, they use different voltages. So before you install the whole system, you got to confirm that what the camera is requiring, it actually confirms with the head-end equipment that is providing the PoE. Okay. So in this case, when it's a PoE powered, you just ignore that power jack here, and you plug in the Ethernet cable that carries the signal, and the PoE, which is power over Ethernet. Okay. All right. Here's an example of a small version of a NVR. Okay. What do we see here? Well, we see the on and off switch. So, okay, and let's see, we have 1, 2, 3, 4, 5, 6, 7, 8 Ethernet ports. Okay. Do we see that this one here is capable of PoE? We don't, but I would look in the manual and just make sure that these ports are capable of PoE, because some of usually they are, but some of them are not. Okay, so you need some additional power for the cameras. And the simplest way is to connect it on your kitchen table and plug in the camera just through the Ethernet jack, Ethernet cable, and see if the camera comes on. But the most common thing would be, of course, the proper thing would be to basically look at the manual and confirm that this thing is here. Now, it also has an Ethernet port that can interface this whole system with the local area network. So you're on a network now. You can, for the purpose of viewing the cameras, for the purpose of setting up the equipment and whatnot. This one here also has a VGA port. Sometimes right now you're going to see the HDMI port as well, in order to connect local monitor. It has some audio inputs and outputs here, quite often not being used. And over here is RS-232, which is for the serial communication. Sometimes you need a serial interface to program. Most of the time, those things are not being used. It has a USB port in order to transfer some of the video if you want. If there's something happened, somebody broke into your house while you were not there, and the cameras have registered, or somebody has made a mess in front of your building, and then you want to record, you want to capture that, you go watch the recording and you want to save that recording from this time to that time, and you can make a file out of it, and you can put it onto USB stick, and sometimes the police will require you, will ask you to give you that, so they can do further things with that. These will be trigger points. They can be connected to motion sensors that operate same as the security alarm, and the purpose of those trigger points is that sometimes, in order to save the space on the hard drive that is on the NVR, the cameras are not recording all the time. Sometimes the cameras record if there's motion there, and the motion sensing can happen in two ways. It can happen through a motion sensor that is in the room, and the motion sensor would trigger one of the points, and one of those points can be programmed to start recording view or signal from certain camera. Okay? Or you can skip all that, and the system can be set up that if the NVR senses that there is a motion in the camera, because there will be a still picture, nothing is happening, but if something moves there, then the signal would change, and that would be recognizable as a motion in the system. So then the camera would the system would record the view from that camera, right? Also, you can see here, you can see two USB ports, one at the back and one at the front. You can connect the mouse to one of them as well. Right? So maybe you could connect the mouse to the one at the back and have a mouse that you could operate the system, because you would have a monitor here, just like a computer monitor. And this here, the front one, would be just to insert your jump drive into it if you want to transfer some information or some of the videos onto a jump drive. Okay. Now, some of the USB ports are supplied with power, and some of them are. I noticed that some of them are not able to supply power. So you should experiment with that first. Just experiment. Make sure, do a test recording, test file transfer, and so on. Just so when the situation happens, then you need to use it, then you know how this particular system operates. Okay. Now, so this would be direct connections. All the cameras would be connected as in a star configuration, because all the cables would home run to this particular location. They will be connected straight into those ports, one camera per port. Now, sometimes what you're going to do is, if you have a system that is, well, way more expanded, you're talking about bigger systems. This is just 8 cameras, but sometimes you have 40, 60, 50, 100 cameras in the system. Then of course you will implement something bigger than this, but you can connect this whole NVR to a network, LAN, local area network, and the cameras can be connected onto a separate switch, which usually would be PoE able switch. So then that switch would be connected also to a network, and with all the programming of the IT of the network setup, could be that this NVR is going to see that switch that is connected to the same network, and is going to grab the signal from the cameras that are connected to the switch. So a bunch of programming is involved, and this would be one of those situations. Here is the main panel here, main NVR. And let's say here, this one of the points here is connected right to the switch, and the switch also has cameras connected to it. Well, that's the reason could be that this could be these cameras could be far away from this, more than 300 feet, and as we know, the Ethernet cable is not able to go any further than 300 feet. Yes, you can implement Ethernet extenders, but it would not be a good idea to implement Ethernet extenders with the cameras, because there's speed is actually a factor. Okay, when it comes to that, you need to have a certain throughput when it comes to that. So it's suggested that you would have no longer than 300 feet end to end, and those cameras here could be another 300 feet because of the distance, right? So then this switch would be recognizable by this main panel, this switch also, and it's a bunch of programming involved. So you can have tree topology here instead of a star topology, which would involve just direct connections to the cameras. Okay. Here, there's a typical solution for a small type of a system. Would be mostly residential or small business. There will be cameras connecting a star configuration here. This NVR would have connection to a local monitor, and it could be a networkable. It could go on internet. You could see or access the system remotely from other locations, or you can use your portable devices such as cell phones or tablet or whatnot in order to access live view, or maybe certain you can actually transfer some of the files onto your laptop or tablet. Okay, now as far as cabling for the security surveillance cabling, Cat5e would be the minimum cabling that is required to connect security cameras. Okay. And that is that it is the last slide here. Okay, cool. So we've gone, well, pretty much it's 11 o'clock. So 1 hour on the spot. Cool. I'm going to post this as well as a repeat, so you're going to have 2 videos that are the same. And again, As a reminder, on our YouTube videos, please watch these two videos. This is your homework. There's also another possible reason I'm giving you this. But this is your homework. Watch these two videos. Fiber optics 1 of 2 and fiber optics 2 of 2. Principles of operation. Jared, thank you. Have a good day as well. And then this is practical applications. And then we're going to designate some time on reviewing this information as well. Okay, thank you guys, and I'll see you when I see you, and have a great day.